Hi folks, it's Joseph D here again. Metal casting, 9th of November 2016. Here I've just cast some motor end shields, some smaller ones. I'll show you my pattern, which we made was this one. I've made them in different sizes, so this is a very small one. It's only about less than 3 inches wide, about 60 millimeters. That's the pattern, made entirely out of perspex. 3mm perspex glued together, because perspex block is very expensive to buy in my country. So I've laminated them together and then made the pattern by gluing all these parts on with super glue. Let's take a good look at the pattern. That's supposed to be the end housing of the motor. There's 2 of these for either end of the motor, and that's where the motor drive shaft comes through. This area here where I'm putting my finger around is where the bearing gets recessed from the back. I put this into a lathe and I bore all this out hollow. So that's our pattern. Pretty cool. Now I'll have a look and I'll show you what we made. Just poured the mould a few minutes ago, leaving it to cool. Now here I'm just using a screwdriver to chip away at the sand. And we should have a replica of that plastic thing that I've just showed you a minute ago, which is the pattern. I'm getting good at this because I practice, but still not 100% perfect. But like I said, I use the filing machine to file out some of the imperfections. Nothing serious, nothing that can't be corrected with a bit of hand filing or machine filing. Still mighty hot. As I say, I thought this must have been about 15 minutes ago. Runner and the riser. Need some more work to chip away all this sand. Sorry about the camera cord dangling down. I'm trying to film as well as do this work. Need a wire brush ideally. See that imperfection there? That gets filed away, so it's the same as the rest of the casting. And I've got 2 of these. There's another one here which I haven't opened yet, but you get the idea. I'll come back in a minute and show you what it's like once I've cleaned these 2 up. So we clean this one up, we get that one out, clean that too, and then I'll put them side by side. Back in a moment. Back again. Before I show you them side by side, this is mould number 2. This is the one that came out of the first mould, which I've cleaned it up to a fashion. This is the second one, just so you know that they're the same ones, made at the same time. First one, second. I just put this one down here for a second and just carry on for a minute cleaning this one up. This is the fun part of any metal casting exercise or job, is to take the mould apart and see what you got. Oh, believe me, I've had many disasters, but now I know how to deal with my aluminium, how to flux it, what temperature to pour up. The best temperature to pour I find is around 650 to 660 degrees. But bear in mind today's a very cold day and it's quite cold here inside the workshop. So I poured this one at 670 degrees. Well, it was probably dropped to about 660 by the time I put my flux in and my degassing tablets, and it came out one of the best ever. No air bubbles or nothing, so I'm really pleased with that. Anyway, I'll get this one cleaned up, I'll put them both side by side, and I'll also show you the patterns. I have different size patterns of these things which I've made, because they're very useful. Right folks, we're back. I've cleaned up these two castings which I just made a few minutes ago. These are the patterns I was talking about. I've made them in different sizes. This is the one we used today, this small one here. But this is the 2015 pattern which I made last year, which I used, which for some of my machine tool motors, it came out very good. The basic procedure of machining these I show you in some of my other videos is where I put this in the lathe and it's bored all the way through. You know, the inside is hollowed. Not all the way through, but it's hollowed up to about 10 millimeters from the end, because this is where we're going to be fixing our fixing screws. This is where we drill and tap in order to mount the motor onto whatever it's going to be driving. So that's the back, that's the front. Of course they go opposite ways like this, you know, to build a motor. Opposite ways like that. Stator is in the middle, which is that thing with the coils, the windings. The motor comes through there with the shaft to drive whatever it's doing. And this flat here on these things here is where I mount the terminal box. On one of these is drilled through to allow the wires to come out and go into the terminal box from the stator windings. So this is today's one. I'm very happy with it. It's the first time I've actually cast something and I haven't got any air bubbles anywhere. So what I'm doing now must be doing right. Just a quick look at my furnace. This is what I used today. Little jeweler's furnace, which has been highly modified with a 3-inch crucible, 3-inch wide by I think it's 130 millimeters deep. Holds enough metal in there for doing what I want. I'm in the process of building a brand new furnace, which is a very deep and tall one, but due to my mother being very ill, I haven't been able to complete this project this year. But now she's on the mend, I hope to continue and complete this project in 2017. Once I get this new furnace up and running, I will post videos on YouTube to show it working. I've still got the 2011 furnace that's shown in my other video, the red one, which is the big nice square one. Now I haven't had a chance to use that yet. I made it, but it was so good I just didn't want to bring it in this grotty workshop to use it. So again, this is my patterns. This is the one we used today, this small one, and this is the castings I got. They need slight finishing off, but overall not bad. That little piece there needs to be filed away so that it's clear like the rest of the ribs here. But other than that, that's what we got. What we do with these, we bandsaw them off with the bandsaw, and then afterwards I mount it in the lathe. I have a jig where which fits onto this boss here, and 4 Allen screws keep the adapter which I put in the lathe. I chuck this adapter into the lathe onto the lathe chuck, and then I screw this onto it, so that way I can spin this round without damaging it. So basically my adapter's made to go in the chuck of the lathe. I fix this in place using this boss part here. This center boss part is a locating area because that's dead central. It locates into a hole which is in the adapter. You know, it locates into a bore that's in the adapter, and 4 Allen screws come through the adapter and screw into holes into this casting which are tapped for 4 holes which are tapped into this casting to clamp this onto the adapter firmly, so I can spin this round on the chuck and bore it through and turn it accordingly, because I can't really cast this with a hollow, it's very hard. So this is the way I do it. I dare say there are other ways of casting this with a hollow, but I can't be bothered. This is the quickest and easiest way. I'll just stick it in my centre lathe, excuse the heater. I'm like the math professor here. I stick it into my BV25 centre lathe and machine it round. And I have a similar adapter from an older casting which I did last year. This is what I'm talking about. The area here is bored so that we have a place for this to locate into. That's mounted like that. 4 Allen screws go through this adapter into the casting all the way around, 4 of them. That clamps the casting solid onto this adapter. which is therefore allows me to chuck this adapter into the lathe. In other words, it's held by the lathe chuck into the machine, and then I spin it round. Check out my other videos, I show this operation going on. So if you browse through my videos, you'll find it. Sorry, I can't give more details here, so I'm very limited on battery time. But this is the 9th of November 2016, and this is the castings which I did, which I'm very, very happy with. This motor is for a small milling machine which I'm constructing, and I've got an induction motor which is a stator, high torque, very long stator with the rotor as well long, and I want to have 2 end caps for this motor to be able to make it into an enclosure, so I can use this motor once it's fully enclosed to drive whatever I want to safely. Of course, once this is all completed, this will be made perfect and it'll be painted nice turquoise blue or green or something like they paint machine tools. Well, this is what I've got now. Sorry I had to talk so fast as I'm running out of time with the battery. Thanks for watching my video. Take care of yourselves, and I hope you like this. Bye. Hi folks, it's Joseph D here again. Just a supplement to this original video. This is more later now, on the 11th of December 2016. I'll show you what we've been doing so far. That's the electric motor end shields we cast last month. They've been cleaned up. Motor's almost together, but it still needs some work with the drive shaft and the rotor inside it. But these castings are looking nice. 4 screw holes to screw the motor together with these screws. M3 times 1 thread. Now this is another pattern. This is another pattern which I've made, which is to do with a faceplate which this motor is going to be bolted onto. Now I want to make a replica of this out of aluminium. This is where the motor is going to mount onto this area here. There'll be 4 holes drilled in these corners for the screws to bolt this motor onto here, and the middle part here will be bored out to allow for this center part of this motor here to locate into. So when we put this up, it's going to be something like this. The idea is from the Unimat SL lathes, the way the motor bracket, and that's the motor's bolted onto it. And there's like a belt drive system on the top to drive the milling machine which I'm building. So that will sit neatly there. The area where my thumb is, that will be the area where the milling drive shaft will come through to drive the mill and the chucks and everything. This piece will be like a standalone unit which is fixed to the milling machine, which drives it all. So what I'm aiming to do today is to make this part out of aluminium and to cast it. Just another look at the motor so you can see how good it turned out. I cleaned some of it up with the filing machine, and you would never know. Even without being painted, it still looks superb. One of these holes, one of these pieces here will be drilled. Probably this one down here will be drilled and tapped to an M12 times 1 thread. Now the reason for that is that's where the cables are going to come out, and we use one of these things. One of these cable cord grips will screw onto there. It screws into that. The nut that goes at the top here, we don't need that nut, we only want to use the main thing itself. So basically we're just using that, just that on its own. This nut that comes here, we unscrew that, because instead of screwing into a nut, we're going to tap the motor here to the same thread that this has, so that this can screw directly into the motor like that, and then the wires will come out to feed it to wherever it's going. Probably 3 wires come out of it, 2 for the mains or whatever, and the capacitor wire as well, which is put together. So it's usually 3 or 4 wires that come out of these motors, and connect it to the capacitor to make the motor start. Reversing the wires to the capacitor in the opposite direction makes the motor go the opposite direction in most induction motors. So that's what I've got to do. So what I've got to do now is I'll just get over there to the shed, set the foundry up, and I'll start making a mould back again. Moulding flask and pattern mould after being ramped, ready to pour casting shortly after top half of mould is ramped. Top half of the mould is now ramped and the mould is put together, waiting to receive the molten aluminium. Furnace is now going, and I've just started to do the melting of the aluminium, just ordinary scrap aluminium. That's my flux and Eco Gas 16 tablet broken up. You only need a piece like that, that's plenty. Degassing plunger. And now all it's just a matter of waiting until this gets up to temperature. And then I'll pour this metal in here and then open it up and see what we got afterwards. Furnace is now melting the aluminium. We're on 447 degrees, going on 448. It's nearly there. When it gets to 650 degrees, I stop it, skim all the dross out of it, add the degasser, skim it again, then put the flux in, give it a good stir, skim it one more time, and then I'm ready to pour it into this mould up here. This is just a quick job. It's always fun to film these things, but hopefully later on I'll be able to open this mould and see a replica of this item, which is going to be my motor bracket for the milling machine I'm building. Want a replica of this in aluminium, so this is what we're making. The back is perfectly flat, gets bored out and everything, ready to receive the motor and to go onto the shaft of the milling machine. In other words, the column of the milling machine what it's going to be driving. So I'll be back to you in a second once I've got this poured and opened and show you the two side by side as a comparison. Right, we have our aluminium fluxed and degassed, and I'm just about to do a pour. Aluminium is at 640 degrees. Brilliant. I never actually thought I'd have enough, because this is one of the biggest items I've ever poured. Oh, it's just a little bit left. Let's get an ingot together quickly. It's amazing, you can never judge the capacity of this crucible. I never cease to be amazed. It's only 80 millimeters by 130 millimeters deep. Ingot poured. Return the crucible back to the furnace safely. Voila! I just let that cool. Be about 10 minutes and then I can open it and see what we got. Actually not bad. I was very worried thinking that I won't have enough alley to fill the mould, because I was supposed to be building a bigger furnace next year. Now I was meant to do it this year, but I ran out of time. But with the good old little jeweler's furnace which I've adapted with the steel crucible I've made, didn't do too bad. This will be very interesting to see what this is like after I open it. Be back in a second, guys. Hi folks, back again. 10 minutes after the pour. This is the most exciting part of any metal casting project, is to open up the mould and see what we're left with, or what we've got rather. So here we go. I couldn't really get it apart because I have to film with the other hand, so I've lifted the whole thing up and it came out just as good as I thought it would be. This was a massive thing to cast with my little furnace. All the smoke is getting sucked up through the extractor and outside. Sorry for the shaky camera, I have to film as well as, you know, show you. It actually didn't come out too bad. Mad hot. Sorry. Trying to speak as well as do it. Not my strongest point. Use a little screwdriver to help me do this. Always meaning to buy a wire brush off eBay, but I never do. But this was a nice easy thing to cast. The edges will clean them up with the linisher and it'll be fine. That piece there sticking out is where the electric motor, which I've cast the end shields for, is going to mount onto. And this will be a belt drive bracket. Same sort of setup like the Unimat SL lathes. So if you Google Unimat SL and you see how the belt setup is, this is how this is going to be. The only thing, this is going to be a little micro milling machine to help me with my locks, as I machine and manufacture locks in my spare time as a hobby. Sorry for the clouds of smoke, but we're getting there. Sand used to do this is Petrobond sand. I like Petrobond sand, despite the smell, it's very good. Always make sure you use Petrobond sand in a well ventilated area, because the oils in it is what makes all this smoke. So it seems good so far, no imperfections or air bubbles. I would say that's one of the best castings I've made to date. I was very worried thinking I wouldn't have enough aluminium in my tiny little furnace crucible, but I did. I think this is probably the biggest thing I can make at the moment. That's really pushing it. Well, not bad though. You get the idea. I'll get this cleaned up under the tap and cooled, and then I'll put them side by side, the pattern and the casting, and you can see. Just before I go away, there's just I'll show you the pattern as it is now here. That's the pattern, that's the product. Try and get more of the product because that corner is covered. So if we move this like so, You can get a good comparison now. That's the cast product. That's the pattern. Not bad. I'll get this cooled down, cleaned up, and I'll put them side by side on the bench and show you. Back in a second. Right folks, last part of the video in the conclusive part. Here's the two pieces side by side. On the right is the pattern. On the left is the casting I've just made a few moments ago. As you can see, it's a perfect replica. This part that sticks out here is where we're going to mount the electric motor to. These areas here will be drilled and screwed. You know, the screws will come through from the other side to screw the motor onto this flange. This area will be bored out to receive the motor. The motor has like a piece on the front of it which locates into this area here. So this will be bored out so that the motor just locates into there like a dowel. Once it's located in place, 4 screws come through these holes which will be drilled here and there in the 4 corners, and the motor will be screwed onto this plate, and from the other side it will drive a belt drive similar to the Unimat SL lathe, and this will drive the milling machine at various speeds. And this is an excellent casting for what I've done. Just needs neatening up on the belt linisher. It'll be fine, and once it's painted it'll be amazing. That's the other side of it. Even the other side came out very good too. I cut the runner and the riser off with the bandsaw and face this up, fly cut it, face it, and it'll be fine. Well, these corners here, the whole thing will be sanded down on the belt linisher all the way round, but it's actually come out very good, better than I actually thought. This is just dirt, it rubs off. I never thought I'd have enough aluminium in that little crucible of mine to actually make such a casting. It's actually quite big, 120 millimeters by 140, and it's about 12 millimeters thick, so it's going to be a nice sturdy bracket. The idea, it goes like this. The motor's mounted here, and on this side here, this is bored through. This goes onto my milling machine to drive the milling machine head, which will be driven by a belt system up here with a big pulley in this area, a little pulley that's mounted onto the end of the motor, and another counter pulley here which will allow me to adjust various speeds. So there's probably something like 10 speeds or so, not sure. Whatever the Unimat SL has, that's what this will have, because I'm using the same system borrowed from the Unimat SL, i.e. the pulleys and things. The only thing I've used different is the electric motor. I've made my own electric motor, which is a 170 watt induction motor, and that's why I've cast all the custom motor end shields which you've seen earlier in this video. So this has been a cool project. I'm very happy with the result. Put them side by side. Yeah, I recommend metal casting if you want to make these hard to find or hard to buy items, or you just want to make something custom made. This is the way to go. Providing you do it safely, you take care, exercise extreme caution, you can have a great time and you can do fantastic work, very useful work. As you can see, I'm actually chuffed, very happy. I never thought in a million years I'd be able to make something like this with just a little furnace. Very cool. Detail on that is amazing. Well, I'll probably put this machine together and I'll make a brand new video showing this machine up and running. Well, you'll be able to see how this was made and pieces of it just in this casting video that shows a little bit of how I started making this machine. Because this is the drive components, which is very essential and it's very important for this machine, because without the drive components in the belt, the machine is nothing. So anyway, I hope you had a good time and I hope you enjoyed watching this video. I wish you all the best, and I hope you'll check out my other videos, and I'll put more on in the near future. Thanks for watching. Bye.